So now that we have seen ways in which to reduce parametric curves to regular curves, let us see when we can work directly with the parametric curve without reducing it to a regular curve. For various reasons, but probably the most common reason is that the parametric curve is something essentially different from the usual curve, say something that does not pass the vertical line test. And so as an example of what one can do with parametric curves without reducing them to regular curves, we will discuss how to find tangents to such parametric curves. And so the way to do this is the following. So suppose we are given the curve. Say x equals x of t and y equals y of t, with t living on some interval between a and b. So to find a tangent, equation of the tangent to this parametric curve at a point, we need two things. So for, let's say, to find equation of the tangent, at a point x0, y0, we're assuming that this point lies on the curve. We need the slope of the curve at this point. Because once we have the slope, then the equation, the tangent, is given by y minus y0 equals, say, m is the slope, m times x minus x0. And so x0, y0 are the coordinates of the point at which through which the tangent must pass, and m is the slope of the tangent. So in general, x0, y0 are not an issue, so the actual problem here is to find the value of the slope. And m here is going to be given by dy over dx at this point, say t0. So here I'm assuming that x0 is x of t0 and y0 is y of t0. So we have a certain moment of time, t0, and x0 and y0 are where our particle is at this point, t0. And the slope can be found by evaluating at t0 the following expression. We need to take dy over dt and divide it by dx over dt. So this expression here is a function of t, and what we have to do is to evaluate it at t0, and this gives us the slope. So for example, let us take the curve. So for the parametric curve given by x equals t squared, y equals t cubed minus 3t, what we need to do is find the two tangents. So this slope, this curve has two tangents at the point 3, 0. So the way this can happen is this curve in fact has a self-intersection at that point. And find the two tangents. So basically this says find equations of these two tangents. So to give an idea for what this curve actually does and how it can have two tangents at a point, let us look at the graph for this curve. And as we will see at the point with coordinates 3, 0, the curve has a self-intersection. So by the way, it is useful to observe that indeed for the value of t, let's see, square root of 3, we get precisely the values of x and y equal to 3, 0. But actually, plus minus root of 3 as the value for t gives us the point with these coordinates. And so to get an understanding for what this curve does, we will use Sage. So this is a software that is basically a dialect of Python, and that will allow us to plot parametric curves. So it has this routine, this built-in routine called parametric plot. So I'm getting, I started typing parametric, and then I just hit tab and it completes the command. And if I want to get some documentation of the command, I would type in the question mark and press enter, and it gives me all sorts of nice examples here of what it can do. So what I did was I typed in our curve here. So I have x is equal to t squared and y is t cubed minus 3 times t. I'm going to plot it for t is between -2 and 2. And so the plot of my curve here looks like so. And so you can see that at 3, 0, indeed, we have a self-intersection on the curve. And as a consequence, there will be two tangents. And so let's see if I can copy. Oh yeah, here it is. So indeed we have two tangents, and so we have one tangent with evidently a negative slope and another tangent with a positive slope. So I'm going to now put this graph in my document. Doesn't look like it allows me to copy it properly. Okay, so then okay, so I have managed to paste in the graph here. And so I'm going to go ahead and try to determine the equations of these two tangents. So as I just mentioned, there are two tangents. One will look somewhat like this, and the other will look somewhat like that. One has positive, another has negative slope. So to begin with, to determine the slope, I need the value of t0. So I already discussed this, but let's go through the details now. So t0 is the solution of x equals 3 and y equals 0. So we'll not call it t0, we'll just call it t. So we have a system of equations, and this is t squared, this is t cubed minus 3t. So it's easy to check that the two solutions you get are plus minus square root of 3. So this system is satisfied by both numbers. And now let's go ahead and compute the slopes. So to compute the slopes, we'll need the value of the function dy over dx. And so what we'll do is we will compute dy over dx. So according to the formula we have here, we need to take derivative of y with respect to t. which is 3t squared minus 3, and divided by the derivative of x with respect to t, which is 2t. So we can simplify this a little bit, and it is equal to the 3/2 t squared minus 1 over t. So for t equal to plus minus 3, here are the values of the slope. The slope that we get, so we have two slopes, m1 and m2, and they're equal to 3/2 times plus minus root square root of 3 squared minus 1 divided by plus minus square root of 3, because we have determined that the point 3, 0 here corresponds to the value of t plus or minus 3, plus or minus square root of 3. And so we'll get 3/2 times 3 minus 1 over plus minus square root 3. So this gives 3 over plus minus square root 3, and this ends up being plus minus square root 3. And so as a result, the tangents, equation of the tangents is y minus y0, which is written right here. So this is y0, this is x0. So we have y minus 0 equals x minus 3 times the slope, and the slope we have determined to be one of the two, plus minus root 3. And so we have that the tangents at the point 3, 0 here have the equations, one of the two equations, plus minus square root 3 times x minus 3. And so when t is minus root 3, we get a negative slope according to this equation, and when t is plus square root 3, we get positive slope. So if you look at this curve here, you will see that as t is increasing, so if t is negative, say minus root 3, then the slope of the tangent is negative. So we get this slope first, this tangent first for t equals minus root 3, and then when t is increasing to 0 from minus square root 3, x decreases to 0. So we're moving along our curves in this direction, along our curve in this direction, until at t equals 0, we're precisely at the origin. So here we have t equals 0. So if you plug in t equals 0, you get both x and y equals 0, which is this point here. And then when t grows from 0 to square root 3, x is increasing again. So we are moving along our curve in this direction until at the point square root of 3, we have the tangent with the positive slope, and that is this one here. And so we have successfully found the equations of the two tangents at the point 3, 0 by first solving this system and determining the corresponding t, and then we just use this formula here to compute the equation of the slope, and then just plug in the values of the t we got from our system, and that gave us the values of the slope to plug in into equations of the tangents. So very straightforward procedure here.